Alrighty then. Hello, hello. For those of you who are new to the channel, which is 100% of you, it's a new channel. Welcome. And to the 0% of you who aren't new to the channel, you're scaring me. I mean, I guess you could be coming from a future video, so welcome from the past? Anyways, we're talking about water today. Specifically, a neat little cell-based water rendering system that I made, which is very versatile. As you can see, you can just paint tiles wherever you need it pretty quickly, and you can get stylized water anywhere. And you can do all kinds of different stylization techniques. You know, you don't have to do the same thing I do in this demonstration. You can sample different textures, you can play around with different colors and settings, mess around with the shader so you can get it exactly the way you need it to. And you don't even have to use it for water either. You could use it for lava. In my game, I use it for like oil and ice. I have a couple of different kinds of water. I'll probably end up adding lava later, and you know, even maybe like a little acid puddle or something like that. So yeah, very versatile, and it's pretty darn fast too. And I'll explain why, but first I'll give you guys a demo of how it might look. So this isn't the best looking demo. If you want a better looking demo, you can check out the demo for my game. Shameless self promo, link in description. But yeah, you know, if you want to give the player the ability to splash water everywhere, or let's say you're making a Splatoon-like game, you know, you want the player to be able to paint everything, then it can be pretty useful for that. Yeah, so there's a couple of caveats before I get into how you can make this system. And well, first of all, let me talk about why it's fast. So the way this works is it essentially, you can take the level size, or if you have a massive level, you'll probably have chunk loading, and so you break up these, you know, surfaces into different chunks. But yeah, so it stores the whole area that you see here onto a tiny little surface, where every pixel in that surface represents one cell. And then you just add some, you know, neat shader magic to it, and boom, bada boom, you got stylized water. But there's caveats to that. The first is that obviously if you have like hundreds of these different kinds of surfaces, you know, and you have 5 different types of water, and you make a different surface for every single color of water or every single color of paint or whatever, yeah, you're probably going to have a bad time. Because essentially you're going to be running a for loop and a draw call for every single one of those surfaces. So you'll probably need to have some more clever solutions for any of those kinds of things. And by clever, I mean just changing the color if, you know, you're using paint or whatever. The other thing to consider is, again, if you're trying to do this system with a giant room and you don't break it up into little chunks, your VRAM is probably going to have a bad time. As well as probably some other weird things you can see if, like, because GameMaker needs to store this, you know, like the tiny little surface into a texture page. So if that quote unquote tiny little surface breaks the texture page size, i.e. if you have a massive room, then you're probably going to get some weird stuff with textures loading in, you know. So if you really need this to be all in one one surface, then you'll have to keep that in mind. You'll probably need some like dynamic texture loading for that case. Another caveat is if you're new to GameMaker, I probably should have mentioned this before, but if you're new to GameMaker, you've never written any GML, or you've never written any shader code, this video is probably not for you. I'm not going to go over how shaders work or any basic GML stuff. There's a bunch of tutorials for that. You can check out Shaun Spalding, DragoniteSpam, Friendly Cosmonaut, any of those GameMaker cats, the GameMaker G's as I like to call them. Yeah, so without further ado, if all that is cool for you, let's get started. So first thing I'm going to do is get rid of the demo object. You can see test here. So that was just so I can show you guys how it works. But we're going to create an object. We're going to call it, let's just call it surface renderer or something like that. We'll call it cell. Cell surface render. It's a long name, but you can shorten it up to whatever you need. All right, then we're gonna make a create event, and the first thing we're gonna do is create a macro, and just for keep things organized, do this. If you're going to be creating this object multiple times, like if you don't want to keep this persistent for whatever reason, then you might want to move your macros somewhere else. But yeah, so we'll have a macro. Actually, we'll, instead of default cell size, we'll call it surface cell size, I guess. We have surface cell size, and this is something that you're going to want to change depending on the needs for your game. In my game, I use a surface cell size of 32. You know, like you could make it the exact same size as like all the tiles that you see here are 32 by 32. So if you want, you could make it just the same size as the tiles that are in your level. But I think it looks nice having it be half of that, but whatever you guys want to do for your game. All right, now we're going to do some setup. So first we're going to make a variable called surface alpha. And basically what I'm doing with this variable is, this is going to be, for lack of a better word, like a global alpha value for every surface that we're drawing. So they're all going to be the same transparency. And you don't have to do it this way. This is just how I did it. You can very easily set the transparency to be something different per each surface, and I'll show you guys how to do that. But for the intents and purposes of this tutorial, we'll just have a global surface alpha value. Now we're going to get the number of cells in the room, and to do that, we get the number of columns and the number of rows. And it's pretty simple to do that. Just get the room width and height, divide it by the cell size. Cool. Now we're going to make a buffer. And I will explain buffers a little bit. So if you've never created a buffer before, don't worry. I will explain that. So a buffer is, you can think of it essentially as a really simple 1D array where you're limited in what you can do with it. You have to define the size for it, but it's way faster than an array. And there's a lot of cool things you can do with it. For our case, it's really easy to create a drawable surface using data that's in a buffer. You know, GameMaker has a built-in function for that, which is really nice. But you can also use it for like saving and loading and a bunch of other things. So we're going to define the size of the buffer. This is like how many, I guess, indexes, like if you think of like an array, it's like how many indexes are going to be in the buffer. So we're going to do the number of cells, because again, you know, we're keeping the data for each cell. And to get that, we just multiply the columns and by the rows. And then we're going to multiply it by 4. So why are we multiplying it by 4? Because basically in this buffer, we're going to be storing RGBA values for every single cell. And that's how we're going to define what is visible and invisible. And so really the only value that matters is the alpha value, but when we initialize the buffer, we're going to initialize all the RGBA values to pure white. And the reason why we want to do it as pure white, you can change that if you want, but the reason why I do that is because it's really easy to take white and blend it into a different color depending on your needs. So we'll be storing the cells as white pixels, and then we'll be doing some cool shader magic to that. So now we're going to put in the buffer type, which is going to be buffer fixed. And what this means is that the buffer is going to stay the same size. Like, we're not going to grow the size of the buffer. We're not changing it in any way. Okay, and then alignment. This one's a little bit more complicated to explain, but basically you can offset, like when you're writing to the buffer, you can offset, like you can have some space in between each data store. But for our purposes, we're just gonna have an alignment of 1, which basically means like whenever you're writing data to it, they're all gonna be next to each other. Okay, and then just initializing these variables. So we're gonna have 2 different surfaces. There's going to be the grid surface, which is the little tiny surface, the tiny little surface where we're storing in the buffer. And there's going to be a draw surface, which is the final surface that's being drawn to the screen that you actually see. If you have a bunch of different kinds of surfaces, so if you have lava, oil, paint, like whatever, then you're probably going to want to store these as an array. But maybe I'll explain that later. We'll see. Okay. So now we're going to set up, like we're going to initialize the buffer using the tiles that we painted in the room. So that way, right when you boot the level, all the water will be loaded in. And the way we're doing this is like we're just going to loop through all the cells in the level. So this can really increase load time if you have a big level. So keep that in mind. Let's see, get ID, but it's not too bad for our tiny little room. Tiny little room is tiny little surface. Got to keep it tiny. I think it is, yeah, TS water, cool. So now we're going to do a double for loop, looping through the columns and the rows in the room. Let's see, it's going to be less than number of columns. Cool. I'll do my parentheses like this. I like doing this for double for loops, but you'll probably hate the way I normally do my parentheses, because how I normally do them is like this. You know, most people, I think they do it like this, but yeah, the reason why I indent it like that is I like seeing where the for, or you know, not in this case because I'm using a double for loop, but normally if I have like an if statement, I like seeing where that block is. In VS Code, they have like a line, which is really nice. That actually draws down, so it's a little bit easier to see that. So I do it, I guess, more the normal quote unquote way in VS Code, but there you go. All right, now we're gonna set, oh, I should probably actually add something to this for loop. 0, and hopefully you guys can't hear the bus outside. Traffic can be pretty loud outside of my apartment. Hopefully it's not too bad on your end. Okay. Cool, so we got our double for loop looping through all the rows and columns, so we get every cell. And then we're gonna do, we're gonna make a variable. So this is cell as int. What we're doing is we're gonna convert the XY position of the cell in the grid, and we're gonna convert it into an integer. The reason why we do that is because, you know, buffers are one-dimensional. So to get the position of the buffer, you have to give it an integer. And when you're working in a grid, you know, that's a two-dimensional thing. But don't worry, the math is really easy. I'll just show you guys. I have like a little script here. Here's another useful function for getting the world position of a cell size. We're not going to use this for this video, that's why it's commented out, but worth having. Anyways, so yeah, this is the function here that we're concerned with. And all it's doing is, yeah, just taking the cell X, the cell Y, and the width of the grid, and that's all we need. And then you do some simple math, and you can convert an XY position into an integer, which can be really nice for a lot of things. So I recommend having that function in your library. Cool. Now we're going to add, or we're going to convert cell position into an integer. And then we have to multiply it by 4 as well, because again, we're storing the RGBA values. So we have to basically skip those every time to get like the right position in the buffer. All right, and we're going to initialize each cell in the buffer with an RGBA value of 255. So we're just going to keep them white, because the only thing that we really need to change is the alpha value. So this is a function buffer poke. This just lets you update the data of a specific position in a buffer. There's some other functions, like there's buffer write, which like you have to set the right position, the read write position of the buffer in order to do that. So this function's a little bit simpler for direct access to a specific buffer position. So we put in our buffer. The offset is the position that we're going to be writing to. The type, now this, I'll explain why or what this is and what this means a little bit more in a second, but we're using, this is U meaning unsigned 8-bit integer. That's what we want in here. And that's going to give you a value of 0 to 255. Again, I'll explain in a second. And then the value we're going to be putting in is 255, since we want it to be white. So this is the R value. This will be the G, and this will be the B value. So to get the G value, all we need to do is add 1. And then to get to the B value, we just add 2. Hopefully this makes sense. Hopefully you're not totally confused and lost at this point. Okay, so what does this mean? What is unsigned 8-bit integer? Why do we want this particular value, besides the fact that it has the perfect, perfect values that we need for storing our GBA information? Well, basically the way numbers are stored on a buffer is, let's say we're going to have here a, if I can draw, that's really bad. Hold on. Help me. I don't have the best board set up here. Excuses, am I right? So this is a byte, and on a byte you got a bunch of bits. 1, 2, 3, 4, 5, 6. Let's see, 4, 5, 6, 7, 8. Okay, cool. So you got 8 bits. Okay, each bit is going to represent a number. Oops, wrong one, hold on. Let me just clean this up a little bit. So each bit on a byte represents a number when it is turned on. Get your mind out of the gutter. So we'll have a check mark for when it's on and just nothing if that bit is off. And the numbers they represent is always going to be double the previous bit. And I'll explain why. First, I'll write this. So, if you want to represent 1, you just say, okay, you check that on, that's 1, this is going to be 2, this is 4, 8, etc. So what if you want to represent 3? Well, do you need an additional bit for it? No, because you can just turn these 2 on, and if you add those 2 together, that represents 3. Pretty simple. So this is how you would count in binary. You have 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, so on. If you want to do this on your fingers, you can too, so. Beautiful hand. 2, 4. This can be useful if you're the type of person who likes, you know, counting on your fingers. So now you're not limited to 5 or 10, but you can get all the way up to actually 31 on one hand, and then on another hand you can get up much higher. I can't remember what the number is, but you have like basically if your finger is up, that represents the bit being turned on. So this equals 31, and then I'm not flipping you guys off at all. No. This is this equals 4. See, I'm not being mean. So yeah, that's how that works. Yeah. So why is this important? Well, basically with 8 bits, we can get up to 255. So we don't really need any more. We could allocate more bytes to representing higher numbers. So let's say we got like two bytes. I'll just erase this for a second. So, you know, we got 2 bytes. Now, draw this out. You know, now we can have this one represent 256. This one would be 512, 1028, and so on. Yeah, and so this would be a unsigned 16-bit. So U16. And unsigned means that we're not representing any negative numbers. It's only a positive integer. So, you know, what if you want to represent like decimal points? What if you want to represent negative numbers? Well, it's a little bit more complicated and outside of the scope of this video, so I'm not explaining that. So yeah, you know, like we could allocate more information, but we don't really need to. And, you know, if you followed along with DragoniteSpam tutorial on converting buffers into drawable surfaces, you might notice that he actually uses unsigned 32-bit integers. The problem with that is I ran into a really nasty bug where if, you know, you have like a large surface, like at least if you're doing this in a larger room size, there's some really weird stuff that goes on. What would happen, you know, despite double, triple, quadruple checking my write positions to make sure that I was writing to the right position in the buffer, for some reason, cells, whenever, like, let's say I would throw a puddle of water on top of a pre-existing puddle of water, it would override the cells directly to the right of it, which is really weird. And it wouldn't override the alpha values, it would just override the color values. And that was really, really strange. I wasn't sure why. Maybe I was like, you know, poking too much and stuff. You know, the system I'm showing you guys today is a little bit more optimized than what I had in my game. But yeah, it was really weird, and I did all kinds of tests, and the only thing that fixed it was turning this into an unsigned 8-bit integer rather than a 32. So yeah, if you're experiencing any graphical corruption, you're trying to use like 32-bit integers, maybe that's the issue. I think what was happening was there's some overflow thing going on with just like the size of the buffer and the amount of data that was being stored, or the amount of memory that was allocated because of using 32-bit integers. But I digress. It may even be a GameMaker bug, I'm not sure. But yeah, 8-bit integers is all we need anyway, so might as well use that. All right, finally, what we're gonna do is we're gonna check if there's a tile in the area, and we're gonna immediately set it to, or set the alpha to fully visible, so that way we can see the water when the level loads. Okay, so we need, not select, we need column and row. So if there's a tile there, we're gonna set the alpha to 255. int, and we're going to do +3, because that's where the alpha is, U8, and 255. Cool. All right, so before we draw this, I'm going to give you guys a demonstration on how, or like a more visual demonstration on how this system works. So I'm going to create a sprite really quick. Where is sprite? There we go. We'll just call it SPR demo. And we're going to set it. I'll start off just by setting it to the room size. Actually, no, I'll skip that. So what we're doing is we're going to take the room size and we're dividing it by the cell size, right? So divide by 16, we got, let's see, 86, 768 divided by 16 by 48. So we need 86 by 48. That's going to be the size of the surface we're creating for this room. Okay, add image. So this is what we start with. We start with like just, you know, an invisible blank surface where every pixel on this surface represents an active water cell. All right, so I'll kind of draw like a river. This is our river. It's beautiful. So it starts with that, and this is like the little tiny surface, little tiny surface. What we're gonna do is when we resize it to the size of the room, we're gonna apply a linear interpolation, and you'll see what happens. Oh, whoops, I didn't resize it. Okay, linear interpolation, and we want to resize it back to the room size. Okay, boom. Now you got fuzzy squares. So this is the start of it, and this is what we're gonna get to when, or like in the first part of this tutorial. Because after this, we can just apply some shader stuff to it, and we can have the shader test like how transparent is the pixel when we're starting off with it. And then based on how transparent that pixel is, we can apply a texture to it by varying amounts. So we're going to start with this. And to do that, we're going to create a draw function. And here, just for testing, I'm actually going to add, I'm just going to copy and paste these in if you guys want these. Give you a second to copy it down, but basically, like, I'm just adding some control to manually update the water positions as we're looking at it. So, you know, yeah, if you need to update any of the buffers in your game in real time, this is how you do it. You just poke the alpha value of that buffer, set it to 0 if you want it to be invisible, or if you don't want any water there, 255 if you do. Okay, now we're gonna start by draw. Let's see, what do I want to call this? I guess we'll call it just draw settings. Actually, no, we'll do draw position. Sure. So we're gonna get the camera position, which you guys can change this to whatever you need for your game. For the purposes of this tutorial, I'm just gonna keep the camera X and Y at 0 since that's where it is in this room. And same thing with, like, you know, your cam width. Mine's just gonna be the room width, but, you know, change it to your actual view width. Okay, cam height, room height. Now we're gonna get the position of the surface that, like, so we're gonna crop out part of the surface, and specifically only the part of the surface that's visible on screen, which in this tutorial, the whole grid surface, not the draw surface, but the, you know, the tiny little surface. You know, normally for your game, you know, like, you only need to draw what's on screen, right? So that's what these variables are doing, is getting the position of where to crop the tiny little surface. So crop X is going to be cam X divided by, what was it, surface cell size? Yeah. Crop Y, cam Y, divided by surface cell size. I guess I could control D these. That's something I learned way later than I should have. Control D is a life changer. Okay, cam W, cam H, crop H, okay. And then one final variable. It's gonna be the scale. I'll call this draw settings. So that way if you need to add any additional settings to it, this would be a good spot for that. In our scale, we're just gonna keep it, you can change it if you need to, but we're just gonna keep it at our surface cell size. Cool. Now we're gonna create the surfaces. So we're gonna check if it's undefined. So, you know, which it starts off as undefined. What is it? Yeah, there we go. Grid surface ID. So yeah, if you don't know this about surfaces, you have to check if the surface exists. Otherwise, if you, let's say, minimize the game window, the surface is gonna be gone. It's gonna go bye-bye. So you gotta check and make sure it exists. That way it can recreate it if need be. Okay. It's going to be, since this is our tiny little surface, we need it to be the size or the like the number of cells. So it's going to be the number of columns and the number of rows. And then now we need our bigger draw surface. So actually, I'm going to control D this. Amazing. Draw. There we go. Draw. Draw. And then this, I'm going to make the cam width, cam height. All right, so made our surfaces. Pretty cool, pretty simple. And we're going to init the draw. So the first thing we're going to do is set our tiny little draw surface according to the buffer data. So we do that by using a function called buffer set surface. And then you put in your buffer ID. Then you put in the surface ID. And our offset is going to be 0. So that's how much you want to offset the data, or like where you want to start the draw data, I think. I don't know, but well, we just need 0. Okay, now we're going to set our surface target to be the draw surface. So not the tiny little surface, because that's getting added on top of this surface. And then we're going to clear that surface. Cool. All right, now we're just going to draw. Oh, we don't need that. Yeah, so we're gonna stretch out the tiny little surface, the tiny surface across the screen. And we're just going to keep it simple. So we're just going to start off with like just regular squares, and then we're going to turn them into fuzzy squares, and then we'll do the rest. But we're going to do surface part extended because we don't need to draw the whole surface. We just need to draw where we're cropping to. So we need the grid surface ID, crop X, crop Y, crop W, crop H. Now you want to keep this drawn at 0, 0, because keep in mind that this surface is representative of the whole room, essentially. Now, if you're using chunk loading, you probably need to draw this where that specific chunk is located in the world, or like the top left corner of that specific chunk. So keep that in mind. But yeah, you want to keep this at 0, 0, because instead of drawing the full surface, we're drawing it where it would normally be at, then we're just scaling it up and then just cropping out what's supposed to be on screen. Hopefully that makes sense. So like you want to keep it at 0, 0 if if you're not breaking this up. X scale, it's just going to be our scale value. And then for now, I'm just going to put this as white. And then we're going to have an alpha of 1. These are the things you're going to want to change on a per surface basis, unless you want to have the shader color your fuzzy squares for you. Then you probably still want to keep it white. But the way I do it is, I have these values here, for every surface can be changed according to that surface. Okay, and now we just need to reset, draw the final product. So we're going to reset target, then we're going to draw our draw surface. You probably don't need to use surface extended if you're not going to be using a global transparency value, but that's just what I'm doing for this video. Cam X, Cam Y, scale is just going to be 1, 1, 0, C white, and then our surface alpha. Cool. So if everything works, we should be able to just add this to the room. Where is our object? There it is. Cool. Just add it anywhere in the room, doesn't really matter. We're gonna run it, we're gonna definitely crash. Oh yeah, oh, it works, look at that. So yeah, this is what we're starting with. Amazing looking water, just gorgeous. Wow, ship it, am I right? So we're gonna fix that. We're gonna start by turning it into fuzzy squares, which is really easy. All we need to do is set up the GPU. And all we need to do is add this function here, text filter, and we're going to set that to true. So what this does is sort of like what I showed in the demo sprite. So that's what this does. It just applies linear interpolation when you're scaling things. And then we're going to want to reset that, unless you want to keep it. Yeah, we'll just do this. Actually, So if you want to scale this up and you want to turn off linear interpolation, you probably want this to be reset here. So that's where I'll put it for now. Text filter to false. Okay, so run it again. And you'll see now we got fuzzy squares. Oh, and we crashed because I clicked. Oh, I see. I actually have the wrong thing on here. My bad. That was from the demo object, so let me do that. Surface and surface. But yeah, okay, so now we have fuzzy squares. Cool. So how are we going to get that to actually looking like water? That's where the next step comes in. And we're going to start by making a shader. We'll just call it like shader cell surface, I guess. So we have our vertex shader and our fragment shader. And in the vertex shader, the only thing we need to do is pass the pixel position into the fragment shader. So we're going to do variant vec3 post. Then we need post equals in position. Make sure you spell those things right. Cool. So yeah, passing that into the fragment shader. And to get that, we will put that here. Cool. Now we're going to set up our uniforms. So what we're doing, the first step of this is we're going to be sampling this caustic texture. And I think I got this from like an Unreal tutorial, but you can find your own caustic texture. The only thing you need is you need to make sure that it's tileable, like so, as you can see, because we're going to be stretching it out across the sides of the room. So that's one way of testing, is activating 9 slice. Cool. Make sure you get that. And it doesn't need to be a caustic texture either. It can be any kind of texture. You know, it could be a Perlin noise texture. It could be a space star texture, whatever you need. So we're going to be getting a uniform sampler, so we can get that texture. We'll just call it caustic texture for now. You can call that whatever you want for your specific texture. And then we are also going to be getting, like, you probably are going to need to scale that texture depending on the size of the level. So we're also going to be getting a caustic scale as a uniform. So the first thing we're going to do is get our starting texture. I'll say this, get texture of grid surface. And to do that, we're going to basically cut that value. We're going to create a new vec4. We're just going to call it color. And there we go. That's our base texture, our base color, and things like that. Then we're going to be getting the current texture coordinates. And we're just going to make a simpler variable. You don't really need this variable, I guess. You know, you could just type in VV text coord every time, but I figured it's a little bit easier to type. That's the thing with shaders, they don't really help you if you screw up, so it's nice to kind of simplify these things. Okay, we got those. Now we're gonna get the caustic or Perlin or whatever whatever dope texture. So we're gonna get the color data. There we go. Oh, and then down here, before I forget this, that's gonna be our end result. So right now, like, it's literally just passing the information. So like, we'd get the exact same thing. We just get fuzzy squares. If we ran it with the shader right now, nothing would happen. So that's going to change here in a second. First, we're going to need a vec2. We're going to call it the texture scale. And that's going to be text coord times our caustic scale that we pass in. So like, we have the texture coordinate, and then it's like remapping the texture coordinate according to the scale, and that's what this value is. Okay, now I guess I could probably rename that to something better, but we're not. Okay, so now we're going to get the color data of the caustic texture, which, you know, for your textures, generally speaking, you're probably going to want white and transparent texture. If your texture has a black background, this isn't going to work, because it'll just look like squares basically. You know, you could change the shader to test for the whiteness of a pixel rather than testing the alpha, but you know, what I'm demonstrating here, it's best to have a transparent to white texture, and that way you can manipulate its color and do all kinds of stuff with it. So where is it? There it is. So we're going to caustic color. It's going to be a texture 2D. We're going to get caustic texture. Try not to spell these things wrong. Then we're going to get the UV position, which is a vec2, and it's going to be the text scale that we get up here. So, you know, the remapped UV coordinate dot x. And then eventually we're going to add distortion to this x value. That's how it gets the wavy effect. But for now, we're just going to get the position straight up. Don't forget your semicolons, or shaders will get mad. Cool. And all we're going to do is just have the squares be completely replaced by the caustic texture. So to do that, we're going to make a float. We'll call it replace alpha. So it's the alpha we want to replace the original squares alpha with. And we're just going to have it, we're going to initialize it to this. So it's just going to replace the transparency to whatever the transparency of the caustic texture is. So it's not going to look great, but hopefully it'll demonstrate what's going on here. And then we'll render that. So final thing, we got to set the final color to the replace alpha. All right, and now we just got to apply the shader to our guy here. So we're going to get our uniforms, and we're going to need caustic sampler. Actually, we'll call it U caustic sampler. Shader get sampler index. And there'll be shader cell surface. The uniform is, of course, caustic texture. Beautiful. And then we need the scale. U caustic scale. And same thing, all this, and we just need scale in here. I think that's all we need. Don't have any other uniforms. Nope. Cool. We're gonna set up those uniforms, and there's gonna be a bunch of uniforms, so I'll put them in a separate little comment space here. For setup shader, we're gonna need to first set the shader to the correct one, this one. Then we're gonna set our texture stage, or stage, whatever, you know what I mean. So U caustic sampler, followed by, one more thing I forgot is we're gonna store the settings of each surface into a nifty little package. No, into a struct. So that way it's a little bit easier to get these things. So call it like config surface settings. We'll call the settings render settings. And our first one, we're going to have the texture that we are sampling. For that, we're going to use sprite get texture, caustic, and then there's only one image, so 0. Text scale, we're going to set it for this space. It's going to be 5.5. So you're probably going to want to increase these, decrease these. You know, you're going to want to change these things for whatever you want your scale to be, and change the sprite to whatever sprite you're using. All right. So I'm going to set the stage to be render settings dot texture. Then, so we're going to be setting a uniform F array, since we're passing in 2 values for the scale, an X and Y scale. Caustic could be scale, and then render settings dot text scale. So we got all of that. Now we just need to reset the shader. I think it's shade. If I can type shader reset, yeah. Excellent. And that should, in theory, work. Unless I forgot something. And crash? Hey, compile error. Okay. What did I mess up? Uh-oh. String not found at... So this is the one annoying thing about... Oh, I see. One annoying thing about shaders is they don't have the most helpful compile errors. And that's just how it is. I think that's all it was. Okay. Let's see. And do we got it? And it's broken. Why are we broken here? Why are we broken? Oh. Okay, I figured out what's going on. This is what's going on. So, oopsies. Yeah, make sure you use get uniform, not sampler index. All right. Now with that out of the way, it should be working. Hey, okay, so this is what I expected to see, believe it or not. Yeah, this looks really ugly. So how do we fix it? Because it's just drawing one thing over here. That's really simple. We go up here, we just got to change one more GPU setting. We're gonna do set text repeat. So this is sort of like when you activate 9 slice or whatever. Like it just tiles any kind of texture when you have this on. And then we will reset it to false down here. Run it again. Hey, now we have the texture across the entire screen. So what happened to our squares? Why aren't the squares having any impact on this? Well, that's what we're going to change. Because remember, when we set the buffer to the surface, we set everything in the buffer to white. And you don't really need to do that. If you want, you could have it only be set to white if it's active. I'll do that just for demonstration purposes. So all I got to do is this. But the problem with this is if you're going to change your buffer in real time, oops. For 1 second, let's get this A value. Okay. So if you change your buffer in real time while having it like this on this day, so now you can see like it's showing which cells are active and which ones aren't. But yeah, you know, it's like it should be updating these buffers as I'm clicking on them, but nothing's happening. And that's because I'm not updating the RGBA values. So you need to make sure if you're going to do something like that, that you have the RGBA values also getting updated like so. I'll be deleting all this in a minute because all we really need is the alpha again. So yeah, now you can see that it's getting updated here. But just for demonstration purposes, we don't really need that. So I'm going to be getting rid of this, getting rid of that. I'm going to be backpedaling all this stuff in here. And then I'll add a little comment here because I forgot to add that this is the A value. All right, so now the next step of our shader is to get it so it's not drawn across the entire screen. So it's going to be a little bit tedious, but we're going to be passing in a bunch of uniforms. Actually, we'll just start with one for now. That way we can at least get it to squares. So we'll start with we're going to make a uniform. Oop. And it's going to be a float. And we're going to call it edge mix. So this is like how much you want to mix the edge of a square with... Actually, wait, no, we don't even need to do this. Hold on. Hold on a minute. Instead, what we're going to do is, instead of setting the alpha to this replace alpha, we are going to be getting the alpha of the square. That's how you get it. So we're going to start with this, and we're going to use this value to test the alpha of that pixel, so that way we can mix it with the texture, the amount we want. But all we're going to do is say, we'll just do this. If alpha is greater than 0.0, color A equals replace alpha. So that should get us back to squares. Boom, look at that. We got squares now. So it doesn't look great, but it works. Now we're going to be adding those other uniforms. So this is going to be a little bit more tedious. You know, I might just cut to the end because there's a decent amount of uniforms we got to put in here. So we're going to start though with uniform float, and it's going to be main, we'll call it main puddle start alpha. So this is basically, it's testing like, okay, where are we on the square? And it's doing that by getting the fuzziness, quote unquote, of the square. So if you're in the middle of the square, obviously the alpha is going to be 1. So what we're doing is we're going to set, like if we set this value to 1, then it'll only set the middle of the square to mix with the other texture a certain amount. Hopefully that makes sense. And then the amount that we mix it by is going to be this uniform main puddle mix. And then we gotta copy this 3 more times and then duplicate this last one more time. Because the way I did it is like you can have as many of these tiers as you want, but I basically have like 4 tiers of sampling. So there's like the main puddle, like the middle of the puddle, the most most opaque, non-transparent part of the square. Then we have one that's like right outside of it. Then we have what I call the splash zone, which is like the very edges of it, and then whatever is left at the edge is going to be the final mix value. So we're going to do outer puddle, we'll call this one splash. Probably not the best name for it, but whatever. Splash, splash, and edge, which is just going to be 0 for us. But in case you want to mix it a little bit more, you can change that. I'll put a little comment saying that these are our uniforms. All right, so similar to what we're doing here, we're going to add these tiers as different if statements. So and mix with its tier. All right, so we're going to have if alpha is greater than equal to main puddle start alpha, right? So that's the uniform where we're testing. Like, so if the alpha is greater than, let's say we set this to you know, 0.9, like that's going to be considered the main puddle. And we're going to probably mix this a little bit more than we mix like the outer puddle, and then and then the very edges are going to be mixed a lot less. So yeah, again, this is how I do my brackets. Sue me. Okay, and then it's going to be an else if, because, you know, we already know if the alpha is greater than this, then we don't want it also doing this at the same time. So these are exclusive. So if alpha is greater than main puddle start alpha, then we're going to mix it by, so we're going to take our starting alpha, we're going to mix it by the replace alpha, which is the alpha of the texture, or the caustic texture, and we're going to mix it by the mix amount. Cool. Now we're going to copy this for the outer puddle, and then this guy, we're actually going to add a secondary if statement in here and do a little bit of nesting. Maybe not the most elegant way of doing this, but hey, it works. Oops, we want this. I'll get to the outer puddle in a second, but we'll do this one first. Oops, if alpha is greater than splash start alpha, alpha, and color A is going to mix that by the splash, and then essentially we're considering everything, all the alpha values below that splash alpha as the edge. And so we're just going to mix that by the edge mix. Cool. Now let's get this outer one, outer, and boom bada boom. So now we should be getting, it should tail off if everything is working. Oh, we got to set the uniforms. Duh. So let's add those uniforms. We'll call it, so yeah, this part's a little bit tedious. Hopefully you're not too bored yet. If so, skip forward in the video and just copy it. U main puddle start alpha. Shader get uniform. Shader cell surface. Yeah, we have to repeat this for all these things. There's probably a better way of doing this, but I haven't thought of that. I ain't smart enough for that yet. One day, maybe, but not today. Okay. I think that's right. All right, there is our uniforms. Just make sure I didn't screw anything up. Splash. Ah, I did screw it up. We want splash. An edge. There we go. Cool. Now we just got to set those guys. So shader set uniform F. It's going to be U main puddle start. Oh, we got to add those render settings too. So again, these are things you can tweak. You can mess around with how much you want to mix it with the texture. You know, tweak all these different tiers, mess around with it until you get something that looks cool. But these were the settings I came up with. We're gonna do. We might as well add, you know, color and stuff to it. We'll just do C white for now. And alpha. Oops. There's one. We're not using these right now, but make sure you use commas instead of semicolons. But we might as well add them. Now we're going to do our main puddle start. And that setting is going to be 0.9. And main puddle mix is going to be an outer puddle start. It's going to be 0.85. Okay, so like basically anything above 0.9 is going to be considered the main puddle, which is going to be basically like the center of the square and like just on the outside of it. And we're going to mix that more with the caustic texture. But then the outer puddle, which starts at 0.85, so it's like a little bit of the edge there. And you can play with these values, you know, if you want to have a bigger outer puddle. But I'm actually going to mix it a little bit less. And the reason for that is because it creates a nice effect where it kind of creates like almost a ring, for a lack of a better word, or like a clear boundary between where the puddle is versus the rest of the world. And to me that looks nice. It, you know, it just makes it look a little bit more clear to the player where water is and where it isn't. But again, you can mess with these all you want. So it'd be outer puddle mix. We're going to mix that to be 0.35. And then our splash start. We start at 0.45. So we get a decent amount of the edge of the square there. And splash mix 0.25. And then our final one is going to be the edge mix, just going to be 0. I'd recommend keeping this value low if you want your edges to be a little bit more rounded. I can show you what it looks like if you mix this a little bit higher, but maybe you want, like, because the caustic texture is transparent in some areas. So maybe you want it to like barely sample a little bit of that caustic texture, so it kind of looks like there's a few drops that are kind of hanging off at the edge. But you know, if you mix it a little bit too much, it can make the water look very blocky and very odd. So but we'll just start with 0 for now. Now we got to set these. Okay, so it's going to be render settings dot main puddle start, and we need it to be a mix. Main puddle mix. Do our duplicating. Cool. Hopefully I got all these right. Fingers crossed. This is going to work. It's going to be perfect. It's going to work perfectly. Oh, hey, look at that. Look at that. So yeah, you can kind of see, like, it looks like it's glowing mostly because of the color, but once you actually add the, like, make it watercolor, it'll look a little bit better. But yeah, this is the effect that we want. These are the settings, you know. So you can kind of see like how it rounds off a little bit here. You can change all of this however much you want to. So yeah, I'll show you guys how to get the color in there, and we might as well have it do the alpha as well. So you set the colors in here, and I got this color. So you guys can copy that if you want this color, but change it to whatever color you need, and we'll set it to that. And if you have a bunch of different surfaces, basically you just want to put all of your surfaces into an array, and all of your surface settings into an array, and make sure that they correspond to one another. One easy way of doing that would be to add an enum, like surface types or something like that, and then you can have, like, you want your first one to be like none or something like that. Then you might have like water, lava, and so on, and then you can just have the render settings correspond with, you know, the enum position. then you can also auto sort arrays and stuff too. I don't know if I'll go over any of that, but okay. Now we're gonna get our set settings dot color, and then we need render settings dot alpha. So again, that's how you you can change the transparency per every surface type. And in that case, you probably want to set, you know, unless you want like them to have like a base level of non-transparency, you might just want to set this alpha to 1, or just have it just draw surface normally. Just have your draw settings be set to 1. That should get us our color, hopefully. Hey, look at that. Now it kind of looks like water, but it's frozen. You know, the water just looks stuck in time right now. So we're going to change that. And this is something called sinusoidal distortion. It's a technique we're going to be using. There's a few other tutorials on this, but I'll briefly go over it. We're going to need a few more uniforms here. So we're going to do uniform float distortion. We're going to get the distortion time. So it's like the current time, or how many frames have passed. Distortion speed, we'll just do SPID. Uniform float. Distortion, the frequency of it. And then finally, I guess we could do that. Size. All right. So with those 4 uniforms, what we're doing is essentially offsetting the X position of the UV coordinate. You could also do it with the Y if you want, and you could separate them, but I think the effect that looked good for me was just distorting where it gets the X position on the scale, or on the texture. So to do that, we are going to create a variable. We'll call it distortion wave. Actually, let's do distortion amount equals sign distortion time times our distortion SPID plus text scale dot y times distortion frequency. So the frequency is, if I'm not getting these mixed up, is like how many waves you're gonna see per linear distort. I don't know how to explain it. I guess like just you can play around with it. There's some other videos on sinusoidal distortion, but you know, you could probably just play around with it for a little bit and see how it works. Distortion size times text scale dot x. Okay, cool. So this will get you your sinusoidal distortion, and then we just add this amount to our x value. All we need to do now is set up the uniforms and our settings in here. So we'll do that really quick. So yeah, there's a lot of uniforms for this, but this is the last bit of uniforms, I promise. And then if you add other things, you're probably going to want, you're probably going to have more, so deal with it. Okay. We got those. Now we just need to add the settings for what we want down here. Distortion SPID. And the settings I found were 0.003. Speed, is that all we need? Oh yeah, okay, because distortion time is going to be gotten from somewhere else. Okay, so we got all those. Now we're going to set those uniform floats. set all them uniform floats. Uniform F. I'm pretty sure F stands for float. I could be wrong on that. So time is just going to be the current time. And then speed. We're going to be doing our render settings dot distortion spid. Copy this. And then we have our freak. Can get freaky with it. Freak and size with size. Cool. So all those things should be set. Hey, look at that. We got nice looking waves now. All right, and if this is all you need, that's the end of the tutorial. But I think what I will do is go over how to do multiple different kinds of surfaces. So we're going to set up some lava. So to do that, what we're going to do is we're going to create an array. We're going to have an array of structs here. Just to make this a little bit more clear, I'm going to do that. This is going to be water. And I'm going to add one more variable to this, which is just going to be, yeah, we'll do ID. And I'm going to set up an enum. Up here, it's going to be water surface, or no, we'll just do like surface ID. Don't need water, especially because one thing is, or the thing we're doing is not going to be water. We got water, and then we'll have lava. Cool, so we got those, and our ID is going to be surface ID dot water. And you don't really need to have that, but the reason why I do it is it's nice for being able to auto sort the array. So this one's going to be lava. Oh, lava. Cool. We'll change the colors and stuff later. And then we'll do array sort, and it's going to be our render settings. Okay, so I had to look up the array function because I wanted to, or the array sort function because I want to make sure I didn't mess it up. But this should, in theory, sort the arrays based on their enum ID. So that way, like, you know, if you add these and you accidentally add some in the wrong position, it doesn't really matter. It's just going to sort them. That way you're getting the right render settings for the right surface. Cool. Now we need to add a bunch of surfaces for the number of surface IDs. Well, I guess we'll just do it based on like the number of render settings. So we need to remove all of these. So it's going to be, we'll just do enit, I guess. Ooh, enit. There we go. And then we're going to set up the surfaces down here. So we're going to need to create a buffer for every one of these surfaces that we want, as well as a separate grid surface. The draw surface is just going to be one, so that's not going to change. We'll do actually what we want. One thing to keep in mind when you're doing arrays is if you're doing like a for loop and you're doing the for loop based on the length of the array, you want to make sure it's fine if you're doing it like, you know, in a create events like this, but generally speaking, you want to make sure to get that value before running the for loop, because then otherwise it's running that array length function every single time. So it's just like a little optimization thing. Get the array length before running the for loop. Okay, so it's going to be render settings, duh. Cool. We got that. And I equals 0, I less than length, I plus plus. Buffer I equals this. I guess we'll initialize these services. So we'll create them on create here. So we're gonna, let's see, gonna get I, and then we're gonna go into here. But we still need to test them. So when we're running the for loop for drawing each of the surfaces, we'll have to test like each of these surfaces to make sure that the surface exists. Okay. So we're gonna do that. We don't need this anymore. I guess I will take that though. We'll call this draw surface. Then after we clear alpha, we are going to run our for loop again. Oops, I didn't need to add an indent there, but I do need to add, we'll just do for like all the render settings. That makes sense. We'll just do what we did before. I equals 0, i's less than array length. And I guess like we don't really need to sort, since I'm just using this array, we don't really need to sort it based on the enum, but that is something you can do if, you know, like you do want this ID for whatever reason. Like if you want to reference a specific surface, for example, then you can do that. But for this, we'll just leave it as that. So, oh, we already have the length. There we go. I plus plus, cool. And we're gonna need all this. Actually, I think we want this shader to be set before. We'll say draw tiny surfaces. And okay, so shader set, and then shader reset would be out there. Then we do this, then we do this, and we set it to render settings I. We just gotta do this for all of these. Oh yeah. Gotta love the tedious copy and paste. Don't need that. Hey, there we go. I could probably break these up, so. Cool. All right, so now we got multiple surfaces. Now we just need to change the color. So let's see, I got this other orangey color in here. Or I guess it's more of a red. So we're just gonna take that. You guys can copy that if you want, but just take whatever color you need. So what do I call it? Water red. I guess that works. Ooh, red. And so I'm not going to change like the tile map or anything like that, but basically you could just add additional tiles to your tile map, and all of those will represent which grid buffer to change. I guess we got to do this for all of them, huh? Okay, so what we're going to do, this is an easier way of doing this, is take that, I'm going to put these in here. We'll set a equals we'll say if tile data is not equal 0, then we set the grid buffer according to what the tile data is. Actually, I'll change the tile map. Why not? Where'd I go in this file? Might as well. So this is just, you know, simple tile set that I used. And just like really simple sprite. Oops, I want to edit. There we go. We're just gonna add the width. I'll just double it. Yes, and then got this to make sure that these are where I want them to be. Pretty close. Put that in there. And then sure. I guess that works. Hey, we'll do that. What? Wait, there. That works. And I guess we'll have like a green one for this. Cool. Go into here. And we will add a little bit of lava in here. Hopefully, unless it crashes. We'll see. So it's probably gonna look kind of dumb, but we'll just add some random spots in here. See what happens. And then for our step event, we'll just have it set water for now, just so you guys can see what's going on here. Cool. Let me double check. Yes, we need this. There's always something you're missing. Okay. So hopefully that wasn't too boring. And, well, we gotta do this too. Hold on. You're there. Set buffer. Grid surface. Oh, and then another thing we forgot is to check if the surface exists. So let's just say setup surface. I believe I have it in here. Set buffer, set surface. Thought I got it at one point, but guess not. Okay. That's fine. It's fine. It's fine. Ooh. grid surface ID I, grid surface ID I equals surface create, and it was grid rows or grid columns, comma grid rows. Okay, hopefully this works. Double check a couple things here. Columns, rows, da, 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 da. All right, let's try it. And let's get a crash. Let me see a crash. Hey, there it is. Auto range, what? Grid buffer, what? But it should work. Oh. Right. We gotta subtract by 1 because the 0 position means that there is no tile there. So yeah, little confusing. There we go. Look at that, and all our tiles are shown. Let's turn those off. Look at that. Now we got some water. We got some water. But yeah, you know, so that's multiple surfaces. You know, I'm trying to see, oh, now we get something a little funky in here. So why is this happening? Well, that's because I'm stupid. I think that's the gist of it. Oh, no. I know what's going on. Okay. Okay. Yeah, because we changed this here. So this is like another thing. If you're going to have it updating like this, you got to make sure you're not just changing the alpha. But if you're not going to update it like this, you should be fine just changing the alpha values. You know, or you could probably figure out how to initialize them all as, or like every single buffer with 255, but this is the easiest way I was able to do it. So we'll just do that. This is not A anymore. It's supposed to be, oops. I'm gonna add a variable just so we have a little bit more control. You guys don't need to do any of this. This is just more for demo purposes. I'm just gonna add a surface equals 0, and then just add a simple controller here. If keyboard check pressed, I think it'd be like VK 1. Oh, I think it's ORD 1. Then we're going to set current surface equals 0, which I know is a little confusing, but it's more convenient on my keyboard for that. So that's what we're doing. And then 2 is going to be 1, just so I can change the different surfaces and you can see them being drawn. Am I missing a parentheses here? Is that why? There we go. Okay, we got that. What we're going to do, current surface, current surface, current surface, current surface, boom, 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 and boom. And then 1, 2, 3. All right, and yeah, these are no longer these anymore. Cool. Now we should be able to draw a bunch of different surfaces. So yeah, we got our water. I press 2. Now we got lava. Look at that. Look at that. Isn't that great? Aren't we all having a good time? Now you can see here, you notice that these surfaces overlap each other. So if you don't want that to happen, it's kind of optional for how you want these things to work. But if you don't want that to happen, so what you can do if you have multiple different surfaces is you can either change the blend mode, you know, so like GPU set blend mode. I won't go over it too much, but like, you know, you can set the blend mode so that they blend together as they're being drawn. You know, maybe you want like, I guess I'll show it for just demonstration. So you could do like BM add. Actually, we'll do multiply, so that way it's not getting so bright. Multiply, is that what it is? BM, oh, BM, is it max? Might be max. I thought it was multiply. Yeah, let's try that. BM max, and then reset. I guess we could do, we don't need these inside of the for loop. So we'll set these out here. Set that here. So this is one thing you can do, is like blend them together. The other thing you can do is, so we're kind of adding them, you can see that they kind of blend more toward white as you add, just to demonstrate the lava. So that's one thing you could do, or every time, like let's say every time you add or remove a cell, you can have it remove any of the other cells. So I'm not going to show that because it's a little complicated, but basically it's like when you do this, you just have to set all of the other cells to 0, or you could have a function that every single time you change a cell to something, that it will automatically reset the buffer to 0 and then override or set all the previous buffer to 0 and then set the new buffer to 255. But yeah, and like, you know, another thing you could do is have multiple surfaces as well, and then have those surfaces draw with a blend mode that will override the other surface. But anyways, that's all I have for you guys. Again, if you have any questions, feel free to comment. You know, I'm always happy to help with these kinds of things. And this is my first tutorial, so it's probably going to be a little bit messy. There might be some random cuts here and there, but hopefully it's not too bad. Yeah, if you want to support what I'm doing, then, you know, of course, like the video, but you can also, if you're feeling extra generous, you can donate to my game, which is on itch.io, which also helps in doing these tutorials, because as I make that, I'm, you know, going to make more of these. And well, first of all, thank you to everybody who has already donated. It's really helpful, and you know, it's really amazing to see that people like this stuff. So yeah, thank you to all you guys. And for the future of this channel, you know, things what you can expect, like obviously I'll probably be putting up more of these tutorials. I need to rework my AI system, so once I can figure out a clever solution to make AI a lot more optimal, I'll probably put a video talking about all the different steps and things that I figure out there. I'll also be putting out a devlog here soon for my game, you know, proper devlog explaining, you know, different challenges and what I'm trying to do and what to expect for the future of that. And then, you know, probably some other fun things. I'm thinking about maybe doing some streams where I, you know, go through different itch.io games or little indie games and doing like a live critique of them. So if you guys are interested in that, of course, subscribe. But thank you guys, and cheers.